In lesson 4.3, we talked about congruent triangles and corresponding parts, and we also have what's called the third angles theorem, and that just says that if we have two angles of a triangle that are congruent to two angles of another one, then the third angle has to be congruent to the third angle of the other just by default. In the example I have triangle XYZ is congruent to triangle RST. And we just follow the congruent statement. And it will allow us to determine what parts are corresponding. The X, the Y, and the Z all represent vertices of the triangle. R, S, and T all represent vertices of the second triangle. So when we're looking at corresponding parts, we almost don't even have to look at the triangle itself. We can connect X and R so that we know that angle X corresponds to angle R. We can connect the two middle points such that angle Y is congruent to angle S, and then angle Z would be congruent to angle T. We can do the same thing with corresponding sides. XY would correspond to RS. So XY would be congruent to RS. YZ would be congruent to ST, also in the same location of the congruence statement. And then XZ and RT would be congruent, also in the same locations of the congruence statement. Can you look at the picture? Absolutely, but this just gives you a quicker way to do that. So we're going to straighten up the page again. Okay, and then for our assignment for the first side of 4.3, you're going to do 1 through 6, where it says, show that the polygons are congruent by identifying all congruent corresponding parts, then write a congruence statement. Your congruence statement is going to be triangle ABC is congruent to triangle XYZ. That would be a congruent statement. Your corresponding parts, you should have 3 statements for the angles and 3 statements for the sides. And then 7 and 8, you're going to use what you know about corresponding congruent triangles to find the values of X and Y. On the next side, this is where it got a little tricky because we have to do some proofs for congruent triangles. It also tells us that 2 triangles are congruent if and only if their corresponding parts are congruent. Corresponding parts include corresponding angles and corresponding sides. The phrase if and only if means that it goes basically both directions. So if 2 triangles are congruent, then their corresponding parts are congruent. And if corresponding parts are congruent, then the 2 triangles are congruent. This is called corresponding parts of congruent triangles are congruent. Then we have an example proof. It says write a 2-column proof. So as you're doing this, you should mark your triangle. We know that AB is congruent to CB. We know that AD is congruent to CD. We know that BAD, that angle, is congruent to angle BCD, and that BD bisects angle ABC. So we have some more angles that are congruent. The other thing that we can add to this, and it's something that we haven't talked about, but is that when two triangles share the same side, that means that the segment that they have, BD, for both of those two triangles that we see half triangle ABD and triangle CBD. BD is a common side, so that means that for both triangles, the length of BD has to be the same. So that represents what's called the reflexive property. So we start out with given that AB is congruent to CB, AD is congruent to CD, and then by the reflexive property, the middle part the bisector has to be congruent. So now we've got three congruent sides, corresponding congruent sides, and then we start out with the angle. They give us a congruent angle. BAD is congruent to BCD. That's a given. And I knew that BD bisected ABC, which means that it creates two congruent angles there. CBD is congruent to ABD, and that's just the definition of angle bisector. And our third angle theorem said that if I have two congruent corresponding angles, then I have two pairs of congruent corresponding angles, then I have a third pair. So that means that BAD has to be congruent to BDC. And now, since I have all congruent sides and all congruent angles, then I can say my triangle is congruent by CPCTC. Corresponding parts of congruent triangles are congruent. So for that last one, you're going to attempt your own proof at showing that these triangles are congruent. So what you want to do is you want to show that all of the angles are congruent to each other, that all of the corresponding angles are congruent. So you should have three pairs there, and all of the corresponding sides are congruent, and you should have three pairs there.